Good morning friends. Today we are going to discuss operational amplifier. Now if we see the operational amplifier block, terminal 1, terminal 2, this is inverting, this is non-inverting terminal, VCC plus minus VEE supply, and this is the output terminal 3, the output terminal. This is inverting terminal 1, this is non-inverting terminal, non-inverting terminal 2, inverting terminal 1. Supply VCC plus VCC minus VCC. Now what are the characteristics of an ideal operational amplifier? First one, ideal operational amplifier input impedance is infinite. Output impedance is 0. Third point is infinite open loop gain. Open loop gain of an ideal operational amplifier is infinite. So A goes to infinity. Z in equals to infinity. Z out equals to 0. Okay. Common mode rejection ratio CMRR, common mode rejection ratio of an ideal operational amplifier is infinity. Or we can say common mode gain, or we can say gain is 0. And operating bandwidth infinite bandwidth. So ideal operational amplifier, it has input impedance is infinite, output impedance is 0, infinite open loop gain, CMRR, common mode rejection ratio is infinity, or we can say common mode gain is 0, and its bandwidth infinite bandwidth. Okay, common mode rejection ratio CMRR is infinite. That means if the inputs of these two terminals are same, suppose VCM is the input of terminal 1 and terminal 2, then output will be 0. Okay, now we will discuss the inverting operational amplifier. OpAmp. Inverting OpAmp. Now in inverting OpAmp, the input is given at the inverting terminal. We have seen two terminals. This terminal is inverting terminal and this is non-inverting terminal OpAmp. So inverting operational amplifier, the input is given at the inverting terminal. This is inverting terminal and non-inverting terminal is grounded. So if we provide a input across the inverting terminal through a resistor Vn, suppose, and there is a feedback loop, and here we are getting the output V out. This is resistor R2, this is R1. So this is terminal 1. At terminal 1, if I consider V1 is the potential, and this is, if this is terminal 2 and terminal 2 the potential is V2, then V2 equals to 0, ground potential. Now we know for a open loop operational amplifier, this circuit is closed loop, having this R2 makes a closed loop. So without this loop, this OpAmp without any closed loop, so this OpAmp having ideal operational amplifier having infinite input, infinite gain. So what will be the output for infinite gain? So if we take that, then the difference of the inputs, this is V2 minus V1, and if the gain is A, then output V0 will be A into V2 minus V1. Okay, now V0 by A equals to V2 is 0 and V2 minus V1, V2 is 0, so 0 minus V1, so we can say V1 equals to minus V0 by A, that equals to minus V0 by infinity, that equals to 0. So V1, at V1 potential we are getting the 0 potential, that is we are getting the ground potential. Though this terminal is not directly connected to ground, but we are having here a potential, that is 0 potential. So this terminal is called virtual ground terminal. So virtual ground terminal, so that terminal is called virtual ground terminal, as this is not directly connected to ground, but we are having here the ground potential. So this is virtual ground terminal. Now V1 is virtual ground terminal, so V1 at V1 equals to, will get the ground potential 0. Now, so how much current is passing through R1? If we want to find out, then I1 is the current passing through, if we consider I1 is the current passing through R2, then I1 equals to V in minus V1 by R1. Now V1 equals to 0, so I1 equals to, you can write V in by R1. Okay, one condition. Okay, now this I1 current will passes through this branch and this branch. Now we know the ideal OpAmp input impedance of an ideal operational amplifier is infinity, so no current will passes through this branch. So this branch no current will pass through, so total I current will passes through this branch, so through R2. Now how much current is passing through R2, that is I1. So I1 equals to, we can write V1 minus V out by R2. Okay. Now I1 equals to V in by R1. V1 is nothing but 0. So minus V out by R2. You can write as V1 equals to 0. So you can write V out by V in equals to minus R2 by R1. So gain equals to minus R2 by R1, or we can write from here that V out equals to minus R2 by R1 into V in. That's the final. So the gain of a inverting operational amplifier is minus R2 by R1, the ratio of the feedback resistance and the ratio of the R1. So R2 by R1, and the output voltage, if you see, the output is phase shifted 180 degree phase shifted of input voltage. So output is 180 degree phase shifted the input value. Put V out equals to minus R2 by R1 into V in.